To flag that we have Curtis Maloney and then Evan Brumley straight after this one too. And then we break an early break for lunch for us. All right, so we have Curtis Maloney with HttpRequest, an unsung hero of Django.
Yay, it's showing up. Okay, hi everyone. I was goaded into this talk by somebody on Twitter. I will just say that up front. I'm Funky Bob on IRC, where I've been helping people for the last 20 years with their various coding problems. I've been using Python since the late 90s, started on version 1.4, believe it or else. 16 years in the Django community. I was invited to join the Django core team in 2014. There is no core team anymore, but that's another story. I would like to thank my employer, Burns Red, for helping me be here today. All right. Now, through my time with using Django, early on I realized that the framework needed to do two things. There were two aspirations that any framework should really be aiming for in making our lives better. The first is to protect developers from the tedious things. So in Django we have the ORM, so that we don't have to deal with raw SQL. We have templates, so we don't have to deal with that. A lot of stuff is there, so you don't have to do that thing you do all the time, and it doesn't have to consume all of your work. The other thing is to protect developers from the dangerous things. These are the mistakes we often make, the little corner cases we often forget, or the security of mistakes that crop up all too often. The goal of this talk is pretty simple. It is not to have everyone familiar with absolutely every aspect of what's in the request object. The goal of this talk is to show you just how much tedium and danger and how many sharp edges that Django is protecting you from just with this one object, and you may not even realize it a lot of the time. A lot of this comes down to the dry concept, the don't repeat yourself, which I often hear being kind of misunderstood and misrepresented. It is essentially you only define something once. You only define it once. That might be a meaningful value to which we give a name so that we can always reference it, or that might be how to test or perform some function. But the benefit of defining it once means that we can correct it in one place and it's corrected everywhere. Another major factor of this is that ideally, from the Zen of Python, everybody reads this, don't we? There should be one, and preferably only one, obvious way to do something. Now let's just a brief overview of what an HTTP request looks like. And I've just seen a typo. You have the headers in blue here, the request path, what's being requested, and then the content of request. This is actually a sample post that I copied from somewhere else, just to see what's in it. So in an HTTP request object, we reflect this, and there are three main groups of functionality. There's handling headers, there's handling URLs and paths, and then there's content handling. And these are the three sections I'm going to address. So, first with headers. Well, Django makes that really easy to access. We have this nice cached object called HTTP headers, which holds all of our headers. So when you don't have to dig through the meta object to find any of it. Now, Django also here is protecting us from a lot of tedious things. So for instance, if anybody's worked with Django for a long time, you might remember having to dig into the meta object to find a lot of details of stuff, but you might have learned along the way that some headers have an HTTP prefix and some do not. So Django remembers this and deals with it for you so you don't have to remember that. Additionally, HTTP specifies using hyphens between words. WSGI supports using underscores. So again, Django is protecting us from this common mistake, so we don't have to remember either way. It's actually got, when it parses the header name, it replaces all the underscores with hyphens, and it remembers to remove the prefix only for the ones that have it. And when you ask for a header, it's also very forgiving in allowing you to use underscores or hyphens. It'll work either way. Next, handling the content type header. Almost all requests will come with a content type header, and if we get one, it can give us a lot of useful details. So we can see here it's telling us it's an HTML content, and in fact, oh, that hasn't formatted well. And in fact, it's UTF-8 encoded, or it might be a multi-part form data and it needs a particular boundary. So we need a way to grab that information and parse it out, and fortunately, this is all done for us. Additionally, we have a function for parsing the headers. Additionally, Django will go and say, hey, if you told us what the character set is, if you told us the encoding, we'll go and find it and remember what that encoding is. We're going to need that later on. This used to use the CGI parse header function from the standard library, which was one of my earliest commits to Django, but that whole package has been deprecated, so it's on the way out. The accept header is the client telling the server, I would like, in order of preference, these different content types. I'm happy to deal with them. So again, Django has a class to help parse all of that out and hand them back to you in a state that's much easier for you to use. You don't have to remember how to parse that header. You don't have to remember how to interpret it. But even better than this, it exposes all of those as a cached property for you to access as a list, and then gives you a nice convenient function to say, hey, are they okay with me giving them this response type? None of these are very complex functions, but all of them are ones you could subtly get wrong if you weren't paying attention every time. So here they are. So next is the host header, which is, how do we know who the client thinks they're talking to? When multi-site hosting came along, this was essential. Now it's just natural and standard for everywhere. We learned this by asking, well, what was the server name that we believe is our name? Or what was the host header that the client sent in their request? Or actually, maybe we're behind a proxy, and so the proxy is telling us who they were accessed as, and who we're forwarding for. So we've got to be able to resolve all of this. You might forget that sometimes. You might try and take a shortcut sometimes, and then the system changes and you don't keep up. So Django takes care of that for us. It has a thing that says, okay, if you're using X forwarded for, then we'll use it if it's present, and if it's not there, we'll use host, and if not there, we'll use our own server name, and then we'll add the ports if it's non-standard. All these little corner cases is just protecting you from. Oh, and this self is secure down at the bottom there, which we saw earlier as a trivial little function, but again, test it once, write it once, don't redefine it. Going further with the host option, get host now protects you from the dangerous things. We've seen the tedious protection, but there's also dangerous. What if that's not the host we think we are? What if that's a host name that we don't think we should be answering to? So Django includes the functionality for the allowed hosts list, which was a known attack back in the mid to early 2000s. And if it doesn't match, and if it's not a valid list, it protects you from that danger. Our next step is URL building. What was the path that the user actually asked for? Well, we've got two functions for getting that, which are subtly different in ways that are detailed, but one's to do with the full path and one's to do with the path that Django's handling, in case we're on a subpath and so on. So under the hood, these are both calling this function getFullPath, which is doing actually a surprising amount of work for what you'd think would be a very simple thing, get me the path. Anybody here remember the late 90s with IE and all of its path attacks and exploits? No? Well, yeah, there's a couple of people as old as me. It was a common problem, and it was a problem that had turned up again and again and again because this solution wasn't centralized. So here Django is going through and it's making sure that the URI path is escaped properly. It's making sure there's a slash if we think there should always be a slash. If there's a query string, we're going to include that and put that in properly with a question mark, and dealing with all of those problems. Again, remembering to do every step that we might forget to do sometimes. Next, the scheme. Is it HTTP? Is it HTTPS? Is it something else? Are we getting confused? Well, there's a request.scheme there, okay? There's a lot hidden behind that, of course. Much like host, there might be proxies in the way. There might be other things that are changing how we resolve this. So again, Django takes the best way to do this, wraps it up in a function, and protects us from that tedium. And you can see here, if we're told to, and you can turn on and off different options and different features, but it will make sure that we get one of those two answers. And if not, the last step there is a hook so that the localized implementation, depending on whether you're using WSGI, ASCII, or some other actual transport host or interface layer, can hook in and say, well, this is how I think it should be implemented. As it turns out, WSGI and ASCII have subtly different ways of doing this. In WSGI, we get it from the environment that's parsed us. In ASCII, we ask the scope, and then otherwise we fall back to the default. Next is absolute URLs. So sometimes you want to include the entire host name, the entire scheme, all of the way, so that you could, for instance, embed it in an email and so on. So again, a lot of tedium, a lot of steps that you might forget. Django remembers them. First, it calls get full path, like we saw before, which makes sure that everything's encoded properly and constructed properly. Then it actually parses what it got out of that, so that it can make sure it fills in the scheme and the host name, or netlock as it calls it, in case they haven't been provided. And then make sure to clean up and resolve all the relative pathing for ... and so on. And finally, IRI to URI encoding, because we can't necessarily give people international codes. We have to encode it properly for consumption on the web. And just a taste of how fiddly this can get. This is one part of the function that's doing it, and it's remembering to check. Does the path start with slash? Does it have, do we have a scheme? Do we have netlock? Do we have ... in there? Do we have / in there? And so on. All these little corner cases that are very easy to forget. Okay, next we have content handling. We've got reading the whole raw body, or maybe iterating rows of data, or reading and parsing the content, or handling the parsed content like form data and files and so on. All of that is stuff that needs to be taken care of. All of that would be tedious if you had to remember how to do it every time. Handling the body, the request object works like a file. So you can access it with read lines, you can iterate it to get lines of data out. All of that is wrapped up for you. And additionally, there's request.body, which if you ask for that, grabs all of the request as a single data blob, byte string, so that you can just do whatever you like with it. Anyone who uses DRF, this is how it gets the data so that it can parse the JSON. Now, this is all wrapped inside a property, which has some more defensive stuff inside there, so that it'll try to protect you from things like if you read a few lines of data and then do an operation that's supposed to operate on the whole body, that's a mistake, almost certainly. So it catches that and warns you. It will raise an error. It also enforces the maximum data upload size, so that if somebody sends you a very, very large post, it will spool it out to disk or handle it some other way, so that it doesn't exhaust the memory and can't be used as an attack vector, protecting you from the dangerous things. Our next step is content encoding. As we saw earlier, the client can tell us about the content type, and we need to make sure that we parse all of the content in the body according to that content type. So when we receive it and when we set that content type, we have to rethink about how we're parsing the get and body, the post data accordingly. So when you set the encoding, Django remembers to clear out if it's parsed the get and post data, clear it out so that next time you access it, it'll be reparsed with the correct encoding. So next we have handling of post data. This will be parsing posted data. It's pretty common practice. There's a standard function for it in Python, but Django does it a little differently to extract the files out for you. But also we've got to make sure, what if the body was sent to us with the wrong content type? We don't want to be treating every post like it's form data when it isn't. And there's two different ways of encoding form data. So it's all right, Django's got you covered. When it has to load the post data in the files, it goes and checks, is this actually a post? If it's not a post, don't do it. We'll just put in some empty values and move on with life. Next, it'll check, have we actually started reading the content already? Then that's a mistake, and we're going to flag that and raise an error. Finally, we'll go and say, okay, what format is it? Is it a multi-part form data? Yep, then we've got to go parse it. Have we already read all of the body? Then we'll go and use that to parse it. Have we already done this? Again, saving you from those things you might forget later on when the system changes. And finally, the other content types, in case they're handled, one is XForm URL encoded, which means it looks just like a query string. And the last case is, we don't know what to do with it. It's a content type we don't understand, so we'll just give you an empty content. And also, I mentioned file handling. So who wants to remember how to parse files out of a form? Who wants to handle that? Just do it once, do it right. What about if somebody sends you an enormous file? Again, let's put a limit there. Let's have Django's handlers go, I can handle that. If it's really big, I'll spool it out to disk and you'll never know the difference. So to handle that, we have upload handlers. You can ask for a list of upload handlers. If you never touch them, they don't happen. A lot of the things in request are lazy, so that we're not doing work if we're never going to need it. If the upload handlers have not been set, we'll go and run through and initialize them, which does a whole bunch of, let's get what you specified in the settings file and go and ask all of them to get ready. But ultimately, you're still in control. You can override the default set of upload handlers for your view if you have a special need. And the last part of this section, which somehow is a lot quicker to talk about this time than when I did this run last time, is handling cookies. Does everybody remember all the subtleties of how to parse a cookie? Correct. So, again, Django takes care of it for you. It's a tedious thing. It's a thing you might make mistakes with. It's a thing that we don't want to have to deal with. We just want to get the answers that we want. So here it is. It's all taken care of for you. There's actually a cooking handling library built into Python, but Django does a bit more on top of that just to make life a little safer. And finally, Django includes a bunch of signed cookie handling functionality. Why would you need signed cookies? Well, I mean, cookies are stored in the browser for a start, so it means you're trusting information from the client. Cookies have a lot of rules about how the browser handles them, who they should show them to. Is it HTTP only? Is it only in secure contexts? Is it only to be used when talking to the same site? Should we allow JavaScript to read it? So, there's a lot of rules there. That's great. Miscreants don't play by the rules, so just because the browser might do all the right things doesn't mean that the client who's talking to you is a browser. So as a result, Django includes getSignedCookie. GetSignedCookie does exactly what it says. It will take the cookie that you've asked for and then make sure that the content in there has been signed with a secret key that you keep in your setup. So you're able to set a cookie with content that the client can see as much as they want, but if they modify it, you can reject it immediately out of hand. Okay, and as I said, this went a lot quicker than last time I did this. Last time it went over 30 minutes, whereas now I am done. That was surprisingly quick. I'm guessing it's the nervous energy speeding me up.
You see, with being done early, now you can field questions.
Now I can field questions.
10 minutes.
Oh, wow. Have we got 10 minutes of questions?
Excellent. Not Russell. Yeah.
Hello, test. You mentioned Django does a little more with cookies than the standard library. Just interested, anything interesting in there that you're doing that the standard library doesn't?
It does mention a few interesting quirks and bugs cited in Mozilla Dev Network. As for why it handles things a little quirkily, is basically, again, to protect you from dangerous mistakes around the world of not every client is implementing their cookies correctly. In fact, if anybody has been around here long enough, you'll know that in the early days, cookies were not a standardized thing at all. Netscape introduced them. There were a wild west concept of how they were encoded and formatted and what the different fields meant, and then they only got standardized a lot later on. And so some of those are still a bit quirky, and it's protecting you from that. I do recommend, by the way, as an adjunct to that, that everybody have a look through the HttpRequest content, because it is really quite easy to read in most cases and very well commented, as you saw in some of those bits.
Does anybody else have a question? Oh, fantastic. Tom?
Hey, what other... Are you able to draw any comparisons to other HTTP request implementations that are in the Python ecosystem? Like, I guess Flask would have one. There's like Starlet, things like that. Are they working at the same layer? Are they similar things?
I have not delved deeply enough to see what's going on. I did mean to include a little story at the beginning of this of what really got me interested in this, which was some years ago I built, as an experiment to learn new upcoming technologies on the web, I built a little web chat service in Django originally, and then I moved it to being a raw WSGI service. And on top of that, I started learning that, I've got to deal with encoding. I've got to deal with breaking this up. I've got to deal with that. And going back to Django, I'm going, how did you deal with it? I didn't know you even did that. Or how did you deal with that? And that's what got me along the line. So I know that Flask builds on top of Workzeug, I believe, who specializes in being exactly that. I have not looked at how a lot of the other platforms are dealing with, but I expect that you'll find a lot of similarity. Starlet, if I remember correctly, was built by somebody who came from a Django background.
It's built by Tom Christie, yeah.
Yeah, so I'm sure there'd be a lot of similar concepts involved, and a lot of the same philosophy in the background of let's protect you from that tedium and from that danger. I think I saw some hands over that way. No? Any other questions?
Hands up for Curtis.
Oh.
A lovely speaker.
Katie getting her steps in.
So Django has these layers, has these extra APIs to protect you from all the nasty edge cases and corner cases of the spec. Are there any legitimate uses for going directly to the metal? What's the decision process of deciding, no, hang on, I don't want to use Django's processing here. I actually need to be dealing with the raw request, manually managing it myself?
I would expect, from my experience, that those are very, very corner cases. I've seen a particular use case where, for instance, the CSRF processing was tripping content reading, and we didn't want it to, so we had to go and sort of sidestep a few things and say, stop doing that, let us take care of this. That was one. You would have to be, I would expect, in a particularly unusual scenario of your own engineering before any of these things really start to get heavily in the way. But again, Django lets you do it. If you don't want to process that as the body, don't access request.post or request.files, and it won't try to parse the content. If you want to read the content yourself, you can. And even if you do access request.body, all of that content is held in a string IO object for you for later, so that you can still get there. If you want to parse the headers yourself, if you want to do all of that yourself, it's still there, it's still held, it's just a layer on top, rather augmenting rather than obstructing your access to all of the raw request information.
And just a reminder, if you're joining us online, please just use the Discord thread and type in any questions. We can ask them here in real life, but right now I'll pass the mic to another question.
Just on signed cookies, Curtis, are they something that is opaque within the browser, or is it possible to use a signed cookie from within JavaScript, perhaps?
No, from what I can see, it's simply signed with a Mac, so it's your content with a Mac added on, so you should be able to still read it and parse it from the client side. But yeah, if you modify it, that's what they're detecting. That's an interesting concept. you could stop using jots and start using signed cookies instead.
There's one behind you there. Highly available microphones.
I could look this up in like 2 minutes, but since we have time, I'd like to ask, since HTTP request headers are case insensitive, do I have to call .lower to compare them to, or does Django?
For the header keys, no,
Yeah,
that's.
the keys.
I will go back to the code there because it actually does. If you look here, the last line of, I can't highlight it easily, the last line of that first parse header name function calls title case on it. So that will normalize all of the casing so that the first letter of each word is capitalized and all the rest are lowercased.
Excellent.
But that does mean that looking up might feel differently about it. Yes, so it normalizes all of them to title case to keep it consistent and standardized. Question up the back there.
Okay, great. I think we've got 4 more minutes, so
We'll fight for it.
Katie's rushing. No, hold on one sec.
Oh, I thought I was going to fight for it.
Just for the online people.
When should I use Django, and when should we consider one of the other Python web frameworks?
Ooh, the eternal loaded question. Just a quick one, because I mean I've been using Django for so long that Django is just what I reach for. My experience of other frameworks such as Flask is Flask can be much lighter weight because you start with almost nothing built in, but that tends to lead to down the track. You add on all the bits that you want in the end, but that means the next project that you go to may choose to use different tools to answer the same solution. So it's not, your skills in a Flask project aren't necessarily as fungible as on a Django project. Starlet is built from the ground up to be asynchronous. So if you want to be asynchronous and go the modern path, that's asynchronous native everywhere. And because it was from somebody with a strong Django background now going to let's revisit the world, it's entirely possible that they've stepped past some of the clumsier bits that we may not want to continue hanging on to and have been able to do it clean. It really comes down to, I find, what you're most familiar with, and if you have specialized needs, which one will answer those needs. I don't feel that any one of them is necessarily particularly the best solution in any case, or how to choose. It depends mostly on personal taste and community or ecosystem. You might find that there's a Flask plugin that does the thing you need, or you might find that there's a Starlet add-on that answers your questions. And in that case, that's probably going to be a better choice.
I think we have time for just one more quick one. There's one.
Pardon me, I'm not doing my job properly.
It's fine.
It's a continuation of my previous question. So you said it was capitalizing, and I kept looking for capitalizing on there, and I didn't see it. But what I did see is that class HTTP headers inherits from case-insensitive mapping.
All right.
So I'm assuming that in a second
there is where it normalizes, and yeah, okay.
You see how there's a inheritance from case-insensitive mapping. So I'm assuming HTTP headers is a special dictionary.
Yes, sorry.
Where lookups are case insensitive. So it doesn't matter what case you use.
There it is. It's in the slide. I just didn't see it this time. Yes,
I think that's the actual answer.
Well, right. So it normalizes the headers as it's parsing them, and then gives you a case insensitive lookup when you ask for them. Again, taking away that tedium, protecting you from the tedious stuff. Okay, is that all?
Can we give one more round of applause to Curtis?